Let's work out the conventional question at the top of the set. Now this is an HKC question from 2006, number 4. So here we've got a parcel on a conveyor belt, and at P the belt is at rest, and then after switch on from P to Q, it moves with uniform acceleration for 5 meters, and the required time is 2 seconds. So part A, we are required to find the to draw a free body diagram of the parcel. You can see that it's under uniform acceleration, so the net force must be to the right, must be constant. But if we look at the situation, the only possible net force, the force acting to the right, must be the friction. So the free body diagram looks like this. There must be a friction to the right to produce the acceleration, and vertically the weight of the parcel must be balanced by the normal reaction. So this is the free body diagram. So let's look at part 2. In part 2, we are required to find the net force acting on the parcel. So you can see that the acceleration is uniform by Newton's second law, F equals to ma. So the first step, we must find the acceleration first, and then we apply Newton's second law. So this is the solution for part 2. Now, firstly, we take forward to the right positive, and we apply the formula S equal to ut plus at squared. It moves 5 meters in 2 seconds. Let me check. Yes, 5 meters in 2 seconds, and u is 0, so we get this equation, and then we get A equals 2.5 meter per second square, and then we apply F equal to ma. So the net force acting on the parcel is 25 Newton. 25 Newton. Okay. Then we come to part B of the question. We are required to sketch the variation of the frictional force conveyed exerted by the conveyor belt on the parcel. So let's look at the diagram. So QR is at uniform velocity, so no friction. But from R to S, it has got a uniform deceleration. And you can see that the distance PQ is smaller than RS. That means the magnitude of the deceleration in RS is smaller than the magnitude of the acceleration. So and also in this interval R to S, it's decelerating, so the friction must act to the left. So with that, we can sketch the the force position diagram. So it's something like this. So at least we know one force, one value of the force. So it's difficult to manipulate. What should I do? So it is 25 Newton. Okay, from in the acceleration region, and then in the final part R to S, the magnitude of the deceleration is smaller than the magnitude of the acceleration. From Q to R, there's no friction. Okay, so the part B should look something like this.